and deflect towards the west. Here it is the western side, so it is giving the direction in the backward side. That is to my back. That is the snow rule. So these two rules are equivalent. Either you can use Ampere swimming rule or snow rule. Right? Now the magnetic field developed by current carrying conductor, it was given by Oersted experiment. Then what is the nature of, what is the shape of the magnetic field around a current carrying conductor? That is to be determined. That is to be found. For this, we take simple activity. Let us take a cardboard. This is a cardboard, right? And the cardboard is held perpendicular to this plane. It is held perpendicular to the plane like this. The cardboard is placed like this. This is the board. For this, we are putting the cardboard in this way. On this cardboard, we are sprinkling number of iron filings, a very small iron pieces, very small, dust like iron pieces. They are sprinkled on this cardboard, and then a wire, straight wire, is passed perpendicular to this cardboard like this. This is the cardboard, and the straight conductor is passed through this in this way, right? It is so, that means the conductor, the wire is perpendicular to the cardboard, and then the ends of conductor is connected across a battery. It is connected across a battery. Then the current is flowed passed through this conductor. Here we have iron filings sprinkled on the surface of conductor. Let us assume the current is passing through this conductor in this way. That means it is vertically upward. The current is flowing through this conductor vertically upward, and the cardboard is placed in this way, right? As soon as the current flows through the conductor, the cardboard is slightly disturbed. It was slightly disturbed. After disturbing this cardboard, we observe that all the iron filings sprinkled on the cardboard, they align themselves in the concentric circles. All the iron filings are aligned themselves in the concentric circular form due to this current carrying conductor. So these iron filings are aligned in the concentric circles. So that means here the current carrying conductor is like this. It is placed vertically, and the cardboard is horizontal, and the iron filings are also placed, sprinkled on the plane of the cardboard. That means here the magnetic field lines. So all this alignment of iron filings represents magnetic field line. That is magnetic field around it. And clearly we can say that the iron filings lying on the plane of cardboard, that means magnetic field is lying on the cardboard. But the electric current is vertical. So from this we can say that the electric current and the magnetic field are perpendicular to each other. They are completely, clearly perpendicular to each other, right? So that means for a straight current carrying conductor, the magnetic field is developed around it. That magnetic field is in the circular shape. It is in the circular shape, right? So the nature of magnetic field around it, around the straight current carrying conductor, is circular. Iron filings are placed, distributed uniformly around it, so they form concentric circles. But one thing also observed, that all the concentric circles are not equispaced. Nearer to the conductor, close to the conductor, the concentric circles are closer. As the distance increases, the spacing between them, the spacing between each concentric circle increases. So, increasing the spacing of concentric circles represents the magnetic field lines are far away from each other, which represents the magnetic field is weaker. Closeness of the concentric circle represents the magnetic field is stronger. That means nearer to the conductor, the magnetic field, strength of magnetic field is stronger. As the distance increases, strength of magnetic field decreased. This is how we show a current carrying conductor develops magnetic field around it, and the shape of magnetic field also determined from this. Here we have to find one more thing, that what is the direction of that magnetic field. Here we are passing the current in the upward direction. If the same current is reversed in the direction in the same conductor, then also same circular concentric circular pattern will be formed. That means nature of the magnetic field developed around the straight conductor is same on reversing the current also, but the direction of magnetic field will be reversed. So that means we have to determine the direction of magnetic field. For the circular we have two direction, one is clockwise and another one is anti-clockwise. So the direction must be determined. To determine the direction of magnetic field around a straight current carrying conductor, we have a rule. That rule is right hand thumb rule. It is right hand thumb rule. In this chapter, you will hear many rules to determine various things. Here we are using this right hand thumb rule to determine the direction of magnetic field around a straight current carrying conductor. Clearly we must know which rule is used for what. That must be known for us. So here it is right hand thumb rule. Let us imagine that a straight conductor is carrying current. Suppose this is a straight current carrying conductor is carrying current in the upward direction. So obviously it develops magnetic field around it. That magnetic field is perpendicular to this conductor. So concentric circles are formed like this. The spacing should be increased. Right? This is the straight conductor. If the same conductor is carrying current in the reverse direction, then also the same pattern will be formed. Same pattern. But here the direction is different. The direction must be determined. It is determined by using right hand thumb rule. What actually the right hand thumb rule says? Imagine that, it should be imagined only. Imagine that a straight current carrying conductor is grasped in the right hand. Grasped in the right hand in such a way that the thumb is pointing along the direction of current. Other fingers are curling in this direction. The thumb is pointing along the direction of current. Curling of fingers represents the magnetic field. So this is the right hand thumb rule. Right? Once again repeating. Imagine that a straight current carrying conductor grasped in the right hand in such a way that the thumb is along the direction of current. Curling of other finger represents the magnetic field. This is right hand thumb. Right? Here you see, if the current is in the upward direction, the magnetic field is anti-clockwise. You can see the fingers are anti-clockwise. Right? Current upward, magnetic field anti-clockwise. If it is reversed, the current is downward, magnetic field is clockwise. Right? So for upward direction of current, magnetic field anti-clockwise. Here it is clockwise. So it can be shown anti-clockwise. This is anti-clockwise. Here it is clockwise.